I want to go over DNA replication and talk about leading and lagging strands and some of the enzymes and Okazaki fragments. Just a little bit of clarification. So let's talk about and orient ourselves to what's going on. So here is my DNA molecule, and it's got some enzymes I want to talk about. So the gray is actually black. So the original strand that's going to open up the DNA molecule is called the template, the original, or the old. And the new ones I'm going to be made is complementary, daughter, or new strand. So they're all terms mean the same thing. So if you notice, we have on one of the originals, or the template, we have a 3' end and we have a 5' end. And then it's anti-parallel, so then the opposite side of the template strand is 3', okay? And this other is 5'. So that's my original or my template. Now, when I'm ready to replicate, make a new copy, an identical copy, I'm going to use, first I need to open up the DNA molecule. Now there are other enzymes involved in this. We're just going to focus on a few. Some of the other enzymes will be used to keep the molecule open. That's kind of the big one, so we won't get into that. So we have a DNA helicase. Anything that ends in ASE is an enzyme. So this helicase is going to unzip or break the hydrogen bonds as it opens up the DNA molecule, preparing for new free-floating nucleotides to attach and join. So it does this at the same time to make it more efficient. Let's talk about the leading strand first. So we have what is called a primer, and the primer is going to lay down on the original 3' end. So that's what this green box is with the 1. And when it has that primer, the enzyme called ASE, ASE, will signal that it is time to start building the new DNA molecule from the template. So when it does that signal, then it's going to start laying down the new, or it's going to build going from 5 to 3'. Remember, they have to be anti-parallel. So it's going to start attaching nucleotides, matching up, so this may be G and C, T and A, etc. So when it does that, so it's already gotten the signal and is starting to put those pieces together, it's going to come in, let's see if I can erase that, there we go. It's going to add our first polymerase, so we're just going to talk about a couple of polymerases here. So DNA polymerase 3, if you just put polymerase, that's fine. It's going to start adding those nucleotides. So the primer has already kicked it off, so let me draw in my, okay? And so this DNA polymerase only moves and builds 5 to 3'. And they call that the leading strand. So the leading strand will always build in the same direction that the replication fork is unzipping. So it's always going toward the fork. And the thing about this one is that it only has to lay down one primase, to start building, and then it just keeps going. On the opposite side, again, so it's going to first lay down a primer, and so here is the first primer here, and so that primase, now when it lays it down, because it's anti-parallel, it's going to build the new nucleotide, the new strand, 5 to 3'. So to do that, you notice it's away from the fork, so it's going to build away from the fork. So again, it's going to take this DNA polymerase 3 and it's going to start moving and attaching those nucleotides and building away from the replication fork. And then it'll come back and it will lay down another primer, ASE, okay? And again, we will have our DNA polymerase 3, and it will go and start connecting A's, T's, G's, and C's, etc. And it will continue doing that in segments. Now they say that this is discontinuous, whereas the leading strand is continuous. It doesn't stop. The lagging strand has to lay down several primers and use several primases to get the synthesis going. So you're going to have these gaps in between. So it'll start here and then it'll go back and it'll lay down another segment. So we have these gaps, and these the gaps have to be sealed up, and that's DNA ligase. DNA ligase. Now these fragments, each of those segments that were laid down because of those primers is called an Okazaki fragment. And so the ligase is going to continue. So the DNA polymerase 3 is going to add the nucleotides, and then you'll actually have another polymerase that helps to remove the primer. So polymerase 1 is actually going to remove the primer and replace it with the DNA, and the DNA polymerase 3 is going to add those nucleotides together. So for this class, just know that the polymerase, okay, is going to add the nucleotides together. We're not going to specify 1 and 3, etc. But I wanted to introduce or talk a little bit about the primers, what starts it. So anyway, if you have any other questions, hopefully this makes a little bit more sense. So again, the big things, leading strand, one primer moves toward the replication fork. The lagging strand will have several primers laid down, primase, and it will build, again, 5 to 3 prime, and everything's anti-parallel, okay, moving in opposite directions. And the helicase.